Hello everyone, welcome to another video on the Data Perspective channel. In our last video, I gave a step-by-step process on how I analyzed patient readmission datasets, and we were able to deduce some very important insights. In today's video, we'll be looking at how I created a machine learning model to predict patient readmissions and also visualize the main features that predicted readmission. So without wasting time, let's dive right in. Now I want to go ahead and create a model for my data, and before I do that, I have to do some pre-processing of our categorical columns. Those are categorical columns. I have to change them to numerical columns. I use the pandas.get dummies for our pre-processing of our categorical column. Then I also went ahead to drop some columns which were not relevant, like the medical specialty column was dropped, and also the readmitted column will be dropped since that is our target variable, right? So it will be dropped from our features. So using pandas.get dummies encoder, I was able to pre-process our categorical columns as our S features, and readmitted, which I have dropped earlier on, as our Y, which is our target variable. And remember, you have to use the dot values because for machine learning we are only using arrays of data. We only need the values, right? So I went ahead to look at the shape of our data. For our S, which is our feature, the shape was 25,000 rows and 47 columns, while for our Y, which is our target variable, we also had 25,000 rows of data. The next thing I did was to check if our data set was balanced. So I used the dot value scan for our readmitted column to see how many rows of data were readmitted and how many were not readmitted. So you could see that we have 13,246 rows of data as non-readmitted and 11,754 rows of data as readmitted. So this our data set is a bit balanced because we just have 2,000 rows of data off. So now I'm going to go ahead and import the modules and packages that I'll be using for modeling. I'll be importing the train test split from the model_selection from sklearn. I'll also be importing logistic regression, random forest classifier, decision tree classifier, voting classifier from sklearn. Then also precision score, recall score, and accuracy score, as I will be using those check how well our model is performing. So the first thing I did after importing our libraries was to split our data set using the train test and split. To split our data set into our S train, S test, our Y train, Y test. Remember, our X is our features, while the Y is our target variable. I also specified that our test size to be 0.3, meaning 30% of our data should be our test size. After doing that, I saved the names of our S features in this names variable here using the s_features dot columns. So now we are going to machine learning, and the first model which we'll be creating is using our decision tree classifier, and we are saving this model as our DTC variable. So we set our random state to be 2, maximum depth as 3, and minimum samples leaf as 0.20. The next thing I did was to fit this model to our S train and our Y train data. Then I predicted on both the S test and our S train data. The next thing was to check the accuracy of our model using accuracy score, precision score, and the recall score. And using the accuracy score on our Y train and our train prediction, we got a training accuracy score of 0.60, which is 60% accuracy. Then we also got a test accuracy score of 60% also 0.60. We got a precision score of 61% and a recall score of 43%. Okay, so next I decided to get the feature importance to see which features were more important in predicting our target variable. So to do that, I use the feature underscore importances on our model, and I was able to get the important features. I just went ahead to create a visualization, and if you can see, our inpatients column was the column that had the most importance in predicting readmission of our patients. And if you remember, when we were looking at our heat map, let me just go back. If you remember, when we're looking at our heat map, you could remember that our inpatient column was the column that correlated more with readmission status, right? So let's go back. So using our model now, it has confirmed that findings which we got at that time. So that's for the decision tree classifier. So the next model we'll be creating is our random forest classifier, and same process, we use the random forest classifier library, which we've already imported already. We set the random states to be 23, our n estimators as 100, and the maximum depth to be 6. Then we save our model as this variable RFC, and we fitted it to our S train and Y train. I went ahead and predict on the S test and also made prediction on the S train using our model which I created. Okay, so when I was done with that, I checked the accuracy, the prediction, and the recall score. Okay, and for the random forest classifier, our training accuracy score was 63%, which is a bit higher than our decision tree classifiers. If I scroll up, you can see that our decision tree classifier, our training accuracy score was 0.60, which is 60%. But for our random forest classifier, our accuracy score was 63%, so it's 3% much more better than our decision tree classifier model. Then you can see for the test accuracy score, we have 60%. Then the precision score was 61%, and the recall score as 44%. Then let's look at our importance, our feature importance for our random forest classifier. So for using the random forest classifier, the most important feature was also number of e-patients, right? But we also had other features like outpatients, the number of emergency, number of medication, and number of lab procedures. Okay, but when we looked at our decision tree classifier, the major one was inpatient and a bit of number of medications and number of lab procedures. Okay, so I also went ahead to tune our random forest classifier, the hyperparameters, and see if we will be able to get some more better results by tuning the hyperparameters, right? I wanted to get the params so that I will know which parameters I'll be tuning. So I use the get params method to get our model's parameters. When I was done with that, I tuned the maximum depth to 3, 6, and 8, the mean samples lived as 0.04, 0.08, and 1, and also the maximum features I used auto, square root, and log 2. So it's going to use these various parameters, and we are going to get the best out of them, right? I used the best hyperparams and best CV scores to get our best parameter, our best CV score, and also the best model. So at the end, our best hyperparameters was using maximum depth of 8, the maximum features was log 2, the minimum samples live of 1. Then the CV score we got, our best CV score was 61%, the best model was this also, while our test accuracy was 61% test accuracy. So using that, I defined a random classifier model too, using this our best model which we've gotten right now. So I use this parameter to define another random classifier model, and I call that ROFC2. I also went ahead and created a confusion matrix so that we're able to visualize the numbers of labels that were accurately predicted and those that were not predicted accurately, right? Then let's see our feature importance. So using this random forest classifier model, you could also see that the most important features is the number of patients. Next was number of outpatients. We also had medication, lab procedures, and emergency. So I ended by writing a report on the insight which I found. So I said I use decision tree classifier as a baseline model and the random forest classifier as comparison model. Firstly, looking at their various scores for accuracy, precision, and recall, the random forest classifier and the decision tree classifier perform slightly the same, with the random forest classifier having an accuracy score of 60%, a precision score of 61, and a recall score of 44. While the decision tree classifier had an accuracy score of 60, a precision score of 61, and a recall score of 43. So the decision tree classifier provides feature importances property that can be accessed to retrieve the relative importance scores for each input features. From the fitted model, we observe that the number of inpatients, meaning the number of times a patient has been admitted as an inpatient, the number of times the patient has been an outpatient, and the number of lab procedures were the most important feature for predicting a patient readmission. While using the random forest classifier, we also retrieve the relative importance scores for each input features. And from the fitted model, we observe that the number of times a patient has been an inpatient, the number of times a patient has been an outpatient, and the number of times a patient has been brought into the hospital as an emergency were the most important feature for predicting a patient readmission. Also, we could see that the accuracy of both models were pretty low. To obtain the best performance of the random forest classifier model, it was tuned using the grid search CV approach. There was an increase in accuracy score by just 0.1, resulting in the model having an accuracy score of 0.61 or 61%. From the tuned model, we observed that the number of times a patient has been an inpatient, the N_outpatients and N_medications were the most important features for predicting a patient's readmission. I also ended this by giving my recommendations. I said, from the analysis above, circulatory diagnosis was the most common primary diagnosis across the various categories of age, aside early middle age, where others as a diagnosis category came first and circulatory diagnosis second. My second recommendation was on the effect of diabetes diagnosis on readmission. The analysis doesn't confirm if diabetes plays a central role in readmission, as there could be other factors causing patient readmissions, but we can deduce that majority of the patients had diabetes as a diagnosis, logically making them occupy a high readmission rate. Then I ended it by my recommendation. I said I would recommend for the hospital to focus their follow-up efforts to better monitor patients who have had high number of inpatient visits in the year before the hospital stay. That is, patients who had currently been admitted in the hospital before. Patients who have had high number of outpatient visits in the year before the hospital stay. That is, patients who had frequented the hospital as an outpatient. Patients who are on plenty medication, patients who undergo various lab procedures, and patients who had been brought to the hospital as an emergency situation before current hospital stay. So these are the importance factors that should be considered, as they have a high probability to determine if a patient will be readmitted or not. These are all the lines of code I used in analyzing this my project. As I said earlier, the link to my GitHub page containing these projects would be added to the description of this video. Okay, so you can go through the notebook and probably copy the code or look how I went about solving this project or task which I had. So if you find this class interesting, kindly subscribe to my YouTube channel, like, and endeavor to share this video to your friends, loved ones, family that you know is interested in analyzing healthcare data. So this brings us to the end of this class. See you in our next